So let's jump right into it. I want to talk about rapidly intensifying hurricanes because we hear this term pop up a lot lately. I think everybody's heard it on the news. It's kind of a little buzzword lately, especially in the past couple of weeks. So, can you tell me what classifies a hurricane as being one that rapidly intensifies?
Yeah, so there's a distribution of intensification rates. Some are negative, it weakens, some are positive, it strengthens. And among that distribution, there's the most rapidly intensifying. And it's somewhat arbitrary, but it's in most studies, it's defined as a 30 knot increase in wind speed within 12 hours. Mhm.
Okay, so you guys put out some new information, identifying different types of rapid intensification. So one of them seems kind of more obvious. Can you break it down though and tell me the two different types?
Sure. We actually think there's a spectrum of types of intensification, but
Mhm.
on the opposite ends of the spectrum are what we call the kind of the sprint mode and the marathon mode, drawing an analogy to like Olympic running events. And so the typical mode or canonical mode, if you will, is what we identify as the marathon mode. It's sort of more gradual, but longer distance. So the typical case goes from, say, a category 1 storm to a category 5 storm. And it takes about a day and a half, maybe 2 days. And our study showed that the opposite end of the spectrum is what we're calling the sprint mode, which is more like a very quick runner in an Olympic running event where it's a burst of speed, but for a short period of time. So in this case, a tropical cyclone might intensify from, say, a category 1 to a 3 and do so in about 6 hours, but then it stops intensifying further.
Can you name some examples that might be recognizable to people of these different types?
One notorious case was Wilma in 2005 that intensified very rapidly when it was southwest of Florida. In that case, thankfully, with regards to the Florida residents, they had lots of warning for that event because it was so far away from Florida when it intensified. The case a couple of days ago, Otis was right near land when it intensified, and so that's a very challenging type of case to forecast for.
Yeah, I want to talk about Otis a little bit more. Can you tell us exactly what happened there? Because I think everybody woke up that morning and said, wait, what happened? Like, who? I've never even heard of Otis. And all of a sudden, Category 5 is making landfall in Mexico. So I know there were several different factors there. Can you explain what they were?
Sure. I'll say I was surprised by Otis as well. We all knew it was there, but we didn't expect it to be a major event. And then it was one of the most rapidly intensifying storms ever observed, according to initial estimates. And what happened is it was in a favorable environment, but the numerical model forecasts, which we rely on for our predictions of hurricane track and intensity, the models weren't very aggressive with the intensification, if at all. Some of them were actually predicting a slight weakening. And so it was a kind of a surprise to everybody. And one of the reasons for that is this area just south of Mexico has very few observations. There's no islands there. There's no other continents. If you go south of Mexico, there's no land for thousands of miles until you reach Antarctica, actually. So there's not a whole lot of people and no radars. And so we rely on satellite observations. And the satellites are really good at seeing the tops of storms and maybe the upper half of storms. And they're not as good in the lower parts of storms. So I think the numerical models probably didn't have a very good sense of the structure of the storm, particularly in low levels. And so the models were sort of handicapped, if you will, by the lack of observations. And that ultimately led to this surprise intensification.
Hmm. Do Pacific hurricanes get less attention? Because I'm thinking of all these other ways that we're monitoring and getting observations. And I'm curious if that's more specific to the Atlantic, like gliders, like sail drones. It seems like we're hitting these storms from all angles and getting all this information. So is that resource just not there in the Pacific?
So sometimes the resources can be there. And you may have heard in the last couple of days about Hurricane Patricia, which was a very rapidly intensifying storm. I think it maybe holds the record for quickest storm to go from a category 1 to 5. That was in a very similar area, just a few hundred miles up the coast in Mexico. And this was in 2015. But in that case, there were a lot of resources there. There was the NOAA Hurricane Hunter aircrafts were there, in addition to the Air Force hurricane hunters, and we had a special field project that involved a NASA airplane that was overflying the storm. And the reason for that is the Atlantic was very inactive at that time, and so
Mhm.
we were able to shift our resources into the Eastern Pacific, and um, this can happen. There does seem to be a bias towards the Atlantic, and that probably has a lot to do with the fact that more storms make landfall on average in the Atlantic. Um, and in the case of Otis, we've had a we've had a fairly active season in the Atlantic, and it's late in the season, and we don't have many resources left, and so um, we didn't think about shifting our resources to this seemingly uninteresting storm. That after the fact, we knew, wow, that was really interesting. We should have had more instruments there. There was one aircraft flight into Otis that I'm aware of. It was an Air Force reconnaissance flight, and that was actually invaluable for tipping off the NHC National Hurricane Center forecasters that Otis was intensifying more quickly than we thought.
Given this new information that you're putting out about these different types of rapidly intensifying hurricanes, is this going to help with warning time or the warning system at all? Do you see this being beneficial to giving people a heads up?
Yeah, we hope so. Um, the idea primarily is to help forecasters understand the different types of intensification modes. And more importantly, we found that these different types of intensification have different physical processes behind them. And in particular, the sprint mode is associated with conditions that are not often studied and not often thought to be potential for rapid intensification. And so that's one way, and we think it'll help, is just better awareness, situational awareness of different types of storms. Another way is it also helps redirect some research into how we can better forecast these events. For example, I mentioned earlier our numerical models and how they use data, to initialize the models. So maybe more effort can be put into the unusual sprint type storms, to initializing the conditions to hopefully better predict those types of events with our modeling systems.
Hey, thank you so much for watching. While you're here, check out some other videos you just may like.